Here we're going to look at exit slip 3.9 here, where we're dealing more with percents. We'll be using some equivalent fractions and looking some other strategies in a way to solve some of these percent problems. And we'll look at a couple of different kinds of problems here in these couple of problems. So first one starts number 1, and 1A and B are similar problems. A says I want to know 30% of 50 is what number? Okay, so I want to know 30% of 50. I don't want to know all of it. I know my answer is going to be less than 50. It's actually going to be less than half of 50 because I know 30% is less than half, because 50% is half. So these are the problems. There are different ways you can look at them. A lot of kids talk about when they see that of, they know it means multiply. That's what they know it means. So I could say 30% of means multiply. Key is here, I can't keep this 30%. You got to make it a decimal, because 30% is 30 hundredths, or 0.3 or 0.30. I don't need the 0 on there, but that is 30% of 50. So they know I can just take 0.3 times 50, and we know if we multiply times a decimal, the answer is going to get less. If I do the work there, we're going to get 15. Okay, I'm not going to take the time to do the multiplying work here, just about the thinking on the percent problems. So in this case, we'd get 15. Another way, you can set up a proportion. If we know 30% means out of 100, I know that's 30 out of 100. That's what 30% represents. I'm just changing it to a fraction here out of 100, because I know percents are out of 100. And I want to know 30% of 50. So when I'm setting this up, I don't want it out of 100 anymore. I want it out of 50. All right, so I'm going to move this over again, kind of in the light here. 30 hundredths equals how many out of 50 now? I'm changing that denominator to 50. So I can see the relationship here. I'm just cutting this in half. So I know if I divide this by 2, I must divide the top by 2, and you see how I get 15 out of 50. So 30% of 50 is what number? Again, the answer comes up 15 when I set up that way. Some people look at it this way. I can find 10%, and that's an easy way to get to 30% because I can just do it 3 times. So how to find 10% of 50? So I could say 10%. To find 10%, I know that's 1/10. So take 50 divided by 10. So I know 10% is 5. So 20% would be 10. And 30% would be 15. Again, another way to think. If you can get it down to, well, it's 10%, then I can just do that 3 times. I could have just taken 5 times 3 to get 15 there. But 3 different ways to look at it there to be able to solve these. Again, they're all similar thinking. One's just doing it with fractions, one with a decimal, and knowing that multiplying, when you say of, my answer should get smaller, so I can multiply there. And then again, a little different way to think about it if I can get it to 10% here. Okay, 65% of 80. Again, I'm just going to use one strategy this time. And I like these. I think these are simpler when I see that of, and I know the answer should get smaller. I'm going to change that to a decimal. 65 hundredths of means times of 80. So a lot of times we can just use a calculator here. We're dealing with percent, so 0.65 times 80, I get 52. And again, that should be less than 80, right? Because I just want 65% of it. And I want over half of it, which is 50%. So my answer of 52 makes sense. I want to do that reasoning there. Again, if I set up a proportion, I could say we have 65% is 65 out of 100 equals what out of 80? Now that gets a little tougher because 100 doesn't get to 80 so easily as it did in this first one where I got it down to 50 by cutting it in half. But could I, for example, do some different thinking here? If I change forms and get this to 10, I know if I divide this by 10, the denominator gets to a 10. So I would also need to divide the top by 10, and I know if I do that, that turns into 6.5 out of 10. That's an equivalent. Dividing by 10, I can have a fraction decimal, just a different way to think about it. And I want to get this denominator now to 80. I changed it to a 10 because I know that's easy to get to 80. I can take it times 8. So then to get my answer, I just have to take 6.5 times 8. And if you do the work there, you will also get 52. So guys, you can do thinking a lot of different ways in these. You just need to get the denominator somehow to 80. Well, I took it to 10 because I knew 10 times 8 would get me to 80. So I had to do some thinking on how I might do that. Again, I think it's a little simpler probably to do this. but it's also good to think some of these different ways. It's okay to have a fraction decimal. It's a little more complex, but the thinking's correct. Okay, so explain how you found 30% of 50. Again, I could write what I talked about here, of means times, and I can convert it to a decimal and multiply, or I could have written, how to change it to an equivalent fraction. We're not going to take the time to write that right now here, but those are things that we could be writing there. Okay, so that's one type of problem where my answer gets smaller because I just want a part of a number. Okay, when we get to number 2 here, you're going to see the situation's a little bit different. Okay, so make sure you have this written down. I'll pause the video if you need it. All right, number 2 here. Here's a different type of a problem, so you got to understand. In this case, it's different than the first situation. Now they're going to tell me 20 is 10% of what number? This time, I'm looking for the total number that I start with. Okay, so the answer should actually get bigger. In the first problem we did, the answers got smaller because I just wanted a percentage of a number. So right now I know 20 is 10% of a number. So I can set this up a couple of different ways. All right, I can do this one way. 10% I know is 10 out of 100. That's 10%. And in this case, I know that equals 20. So it's not the denominator. What I'm missing is the total. So this 20 is now the numerator. Because 10 out of 100 is 20 out of what? I'm missing that total this time. So I can then see the relationship. Well, all I'm doing is doubling the top to get it to 20, so I need to double the bottom. And then 200 becomes my answer. 20 is 10% of what number? All right, so if I'm setting it up like this, I know I'm missing that bottom number, and I can see that relationship to get it to 200. Another way to think about it. 20 is means equals. 20 is 10% of a number. I know I'm missing the total, so I need to get this thing to 100%. I want to get to 100%. Well, if I know 10%, can I do that 10 times to get to 100%? So I must simply do this 10 times as well. So 20 times 10 is 200 equals 100%. So I can do it both ways. 10% is 20, so that means 100% has to be 200. I need 10 times more to get to 100%, so I got to do 20 10 times to get to 200. So there's another way to think about it to help you solve a problem like this. Same problem here. 35 is 20% of what number? Okay. There's also an additional way you could think about this one. Some of you know that 20% is 1/5. So 35 equals 1/5 of what number? I'm missing the total. Okay, so if I've got 1/5, how many times do I need that to get to 5/5, or the whole? Okay, if I do this 5 times, I get to the whole number that I'm missing. So I can simply just take 35 times 5, and I get to the whole number that I started with. That's 1/5 of it. Do it 5 times, you get it to 5/5. So I could just simply take 35 times 5, and you get 175. So 175 could be my answer there if I thought about that way. If you know 1/5 is 20%, do that 5 times, because I know 20 times 5 gets me to 100% of the whole number. So I can just take 35 times 5. All right, 120 times 5 gets me to 100%. I'm trying to get to 100%. That's just like if I did 35 is 20%, the thinking like we did on the last one. To get this to 100%, you take it times 5. So that's 100%. I must take this times 5 as well, and we know that gets me 175 for my answer. Again, I can set it up as a fraction if I'd like. I'll show it one more time. If we know 20% is 20 out of 100, percents are out of 100, and then, so what is 35 out of what I'm missing is, what's the denominator? What's my total now? Okay, this is a total. So it's a little tougher when I do this because 20 doesn't get along very well with 35. So I got to change this maybe to a number that can get to 35 a little easier. So my brain, I see I can divide both of these. A common factor is 4. Because if I divide both these by 4, it's going to change. I'll move it down here to 5/25 in simplest form. 5/25, and not in simplest form, but in a lower form. And the reason I did that, guys, is because I know the top needs to get to 35. Well, what do I do to the 5 to get to a 35? I can take it times 7. So that means I need to take the bottom times 7. And if I take 25 times 7, I'm going to get 175. And again, there's my answer. Okay, 7 quarters is 175 cents, right? So 25 times 7 is 175. All those different ways of thinking, guys, get me to my answer. There's multiple ways you can answer these things. Again, we're trying to understand percents at a higher level, and the more of these we can understand, guys, the more deeply you're understanding these types of problems and how percents work.